Hello everybody, this is the notes for Advanced Geometry section 3.5. In the previous section we talked about just slope, how to find the slope, how to tell if lines are parallel or perpendicular from their slope. So that was just slope. Now in this section we're talking about writing the equations, graphing lines from the equation. All right, we're going to be dealing with two formats for an equation for a line. The first one, slope-intercept form, most common one. And the other one is called a standard form, which is actually easier to graph sometimes. So they both involve intercepts, where the lines cross your x or y axis, so they're individually called y-intercept or the x-intercept. All right, slope-intercept form, the most common one. There we go. So, slope-intercept form, y equals mx plus b. It's this giant equation in the upper left corner here. M is the slope of the line. That's just this value. All right? B is the y-intercept. So, if we had an equation, y equals 3x minus 4, the slope is a number, okay? It's just 3. It's whatever the coefficient of the x value is. Do not put the x there with the slope. That has nothing to do with slope. Slope is a ratio. It's a number. All right. The y-intercept is at -4. So if we were to graph this line, it starts at -4. It's where it's crossing the y-axis at -4. And it's got a slope of 3. So you would go up from this y-intercept. You go up 1, 2, 3 over a positive 1. I should probably do that in different colors. Starting here, you're going up 1, 2, 3 over a positive 1. Now, everybody all together, how many points does it take to form a line? Good. Just 2. There they are. So that would be the line. It's got a slope of 3, y-intercept at -4. All right, for this first official example, I want you to write the equation of the line in the slope-intercept form. So, the b value is the y-intercept. That's where it crosses the y-axis. That's right there, -1. So for our equation, y equals, the plus b part is a -1. So plus a -1, same thing as -1. Now the slope, like we talked about in class on Monday for section 3.4, we're going to go from point to point. We're going to go up 1, 2. There's our rise. The run is going over 1, 2, 3. So rise over run. Rose 2, ran 3. That's our slope of 2/3. So we got a slope of 2/3. We got a y-intercept of -1. Plugging in these m and b values into the equation, y equals 2/3 x minus 1. Okay, for this second example here, it says write an equation of the line that passes through those 2 points. Well, you need to have your slope. So that's the first thing we got to find. Difference in the y values over difference in the x values. So that's 3 over -3, which is a -1. That's our slope. So now, to get the y-intercept, what we're going to do is just plug in our slope into the generic equation. Y equals -1x plus b. Okay, we're missing the y-intercept. We have 2 points. Okay, choose one of them. It does not matter which one, but choose one of them. I'm going to choose the 1, 2. Okay, that has an x value and it has a y value. Plug them in. So the y value is 2. That equals a -1 times the x value of 1 plus b. This is how we're solving for b. We found our slope. We plug it into the generic equation. We had 3 unknowns, y, x, and b. Choose one of your 2 points. You plug them in for x and y. Now you've only got 1 unknown. That's the b value, and that's what we're looking for. So 2 equals a -1 plus b. Add 1 to both sides. B is 3. So our equation, plug in our slope and y-intercept into the generic form, -1x plus 3. And you don't need to put the -1. you could just put negative x plus 3. Either one of those is perfectly acceptable. All right. Write an equation of the line that passes through the point 1, 5 and is parallel to the line with that equation. Again, from section 3.4, we know that parallel lines, they have equal slope. This line has a slope of 3. It's the m part of the mx plus b. So our line is going to also have a slope of 3. So we know the slope. Just like the last example, what we're missing is the y-intercept. This line that we have, it has to go through this point. So there's your x and y values. Plug them in. This is how we're finding the y-intercept. So we got 5 equals 3 plus b. B is 2. So the equation of our line that goes through the point 1, 5 and is parallel to that given line is y equals 3x plus 2. They're parallel. They have the same slope. Okay, the next format for an equation for a line is called standard form. That's what it looks like. ax plus by equals c. The main thing about this, both a and b, they cannot be 0. One of them can be, but not both. There are some other detailed rules about being in standard form, but this is the general idea of it. All right, to graph from standard form, what you are going to do is you're going to find both the x and the y-intercepts. So to find those, to find the x-intercept, what you're going to do is plug in 0 for y. To find the y-intercept, you're going to plug in 0 for x. Okay, and I'll talk about that a little bit in class, but basically, I'll do it right now. Y-intercepts, anywhere along the y-axis, any point on the y-axis has an x-coordinate of 0. Anywhere on the x-axis, you look at any coordinate on the x-axis, the y-coordinate is 0. That's the idea. Okay, so to graph this, again, it only takes 2 points to form a line. So if we find the x and y-intercepts, there's our 2 points. So I'm going to start by plugging in 0 for the y value. And as you do a couple of these, it gets really quick. 3 times 0 is 0. So we got 2x minus 0. That's just 2x equals negative 12. That means x is negative 6. All right. For the y-intercept, I'm going to plug in 0 for x. 2 times 0 is 0. 0 minus 3y is a negative 3y equal to a negative 12. Y is 4. There's our 2 points. On the y-axis at 4. On the x-axis at negative 6. There's our line. Okay? Kind of easy. And what you'll see happens for these x-intercepts, when you plug in 0 for y, that term is just going to go away. So you're just left with 2x term equals negative 12. Same thing's happening for the y-intercept. When you plug in 0 for x, the x term just goes away. So you're left with the y term equal to that constant. It becomes pretty quick and easy. All right, I would like you to try this problem by yourself at home. Come into class with this hopefully worked out and solved, and we'll talk about it first thing in class. Have a good night.